Welcome to the deep dive. In 2025, we're hitting a pretty significant milestone, the 30th anniversary of JavaScript.
30 years, yeah. It's kind of hard to believe.
It really is, especially when you think it started as this weird little scripting language developed in 10 days, and now it's basically the backbone of the web.
It's a remarkable story for sure. And to dig into this, we're looking at a great resource today, a blog post from Deno.
Right, published really recently, May 22nd, 2025. It's called A Brief History of JavaScript.
Exactly.
And our goal here isn't just to, list off dates. We want to really get into the key
To
moment.
understand the why.
Yes. Why were these moments so important? What really drove this transformation? We want to give you a clear picture of how JavaScript got here, and maybe, just maybe, a peek at where it's going.
Okay, so where do we start this journey?
Mid-90s. Right.
Mid-90s. The web was very different, mostly static HTML pages.
Very static.
Then December 94, Netscape Navigator 1.0 launches.
That was huge. The first really popular browser with a graphical interface made the web accessible.
Totally. It supported HTML 2.0, and that kind of set the stage for, well, something more dynamic.
And that dynamic element came in May 95, when Netscape tapped Brendan Eich.
That's the moment. They asked him to create a scripting language. The brief was interesting.
Yeah, it looks like Java, but object-oriented without classes. That sounds tricky.
It was a fascinating challenge. And the fact he pulled it off in 10 days, just incredible.
A day?
Astonishing, really. And the name, JavaScript. It's a pure marketing genius riding the Java hype wave.
Absolutely. Smart move. Then came the official announcement, December 95, Netscape and Sun together.
Right. Positioning it as this open cross-platform language for the internet, but also for enterprise networks.
They had this vision, didn't they? Java objects on the client, manipulated by JavaScript.
And they had backing 28 tech companies right out of the gate. Showed it had real momentum.
That support was key. But then, competition arrives, March 96.
The browser wars ignite. Microsoft launches JavaScript in Internet Explorer 3.
Clever name, avoiding the Java trademark issue.
Very clever. And JavaScript had its own tricks, didn't it?
Yeah, that ActiveX object integration with Windows, connecting to Excel from a browser, that must have seemed futuristic then.
For some businesses, that was a huge selling point, a real differentiator in the Microsoft world.
Also in March 96, JavaScript itself actually debuts with Netscape Navigator 2.0.
Yes, but just as important, maybe even more so in the long run, was the document object model, the DOM.
Okay, the DOM, we hear that all the time now. But back then, what did it actually let developers do?
Think of it like a map of the web page. It gave JavaScript a way to see and, crucially, change everything on the page, the text, the styles, even the structure itself.
So that's the key to making pages interactive.
That was the key. It unlocked dynamic web content as we know it.
Okay, so now we have two competing versions, JavaScript and JScript. Things could have gotten messy.
Very messy. Which is why Netscape made a really crucial move in June 97. They submitted JavaScript to Inksmang International for standardization.
To prevent the web from just fragmenting completely.
Exactly. Imagine writing totally separate code for Netscape and IE. Standardization prevented that chaos.
And that gave us ECMA 262, the spec, and the official name ECMAScript.
Right, because of trademark issues with JavaScript. So JavaScript and JScript became dialects, essentially, of ECMAScript.
And they formed TC39 to guide its evolution.
Yes, that committee became the steward of the language, guiding how it would change and grow over time. A really important step.
Okay, so we've got the birth, the early competition, and standardization. Heading towards the late 90s, the open source angle starts to come in, right?
Big time. January 1998. Netscape was losing the browser war.
Yeah, IE was gaining ground fast.
So they made a really bold move. They open source Navigator.
Which didn't save Navigator itself, but led to the Mozilla project.
Exactly. And think about what came out of Mozilla. Firefox, obviously.
Tabbed browsing. Can you imagine browsing without tabs now?
Right, browser extensions.
Yeah.
Even the Rust programming language has roots there. The impact was massive.
Truly profound. Okay, so on the language standard front, ECMAScript 2 came out in 98.
Yeah, ES2 is mostly about aligning the standard with ISO standards, kind of housekeeping.
Yeah.
But ES3, in December 99, that was a big one.
The blog post calls ES3 the point where JavaScript became a serious programming tool. What made it serious?
It added so many fundamental things. Do-while loops, regular expressions for text processing.
Jack's essential.
Totally. New string methods like concat, match, replace, slice, split, stuff you use constantly. And really importantly, proper error handling with try.catch.
Okay, that really does sound like the building blocks for more complex applications.
It absolutely was. Around the same time, March 99, Microsoft did something else quietly significant in IE5, XML HTTP request.
Ah, the precursor to AJX.
Pretty much. It was the first real way for JavaScript to send an HTTP request back to the server without reloading the whole page.
It seems simple now, but revolutionary then.
Completely. It laid the groundwork for, well, the modern interactive web.
And as the code got more serious, documentation needed to get serious too. JSDoc, April 99.
Yeah, like JavaDoc for Java. A structured way to comment and document your JavaScript.
Which helps with tooling, right? Like IDEs understanding your code.
Exactly. Better tooling, code completion, automatic documentation generation, very professionalizing. Still important today. You see it in Dino and places like that.
Then, fast forward a bit to April 2001, the first JSON message is sent.
JSON, JavaScript object notation. Looks so obvious now, right?
Just simple text for data. But it beat XML for a lot of web stuff, didn't it?
Oh, yeah. Much less verbose, easier for humans to read, easier for JavaScript to parse natively. It just fit the web better for many use cases.
Early 2000s, focus shifts a bit to code quality. JSLint, June 2002.
Douglas Crockford's JSLint, the grandfather of all JavaScript syntax checkers, as the post says.
What was its impact? Kind of opinionated, wasn't it?
Very opinionated. It basically said, JavaScript has some weird parts, let's avoid those and stick to the good parts.
Which led directly to his famous book, JavaScript, The Good Parts.
Exactly. It pushed for better coding habits and influenced a generation of developers.
Meanwhile, on the browser front, things were heating up again. Mozilla's Phoenix 0.1, September 2002.
The bird rises from the ashes of Netscape. Phoenix was the early version of Firefox.
And it felt like a real alternative to IE, which had become dominant.
It really did. Faster, cleaner interface, tabbed browsing was a huge draw, better pop-up blocking. It brought competition back.
And Apple steps in too. January 2003, Safari and WebKit.
Huge for Apple. Ended their reliance on IE for the Mac. And WebKit, the engine behind Safari.
They open sourced that, right?
They did. And WebKit became massively influential. It's the basis for Chrome's original engine, Blink, and of course, mobile Safari. Big impact on the mobile web.
Okay, now we absolutely have to talk about AJX. Gmail's beta, April 2004, felt like the future landed.
It really did, that smooth, interactive experience without constant page reloads. It showed what was possible with that XML HTTP request thing we mentioned earlier.
Just a totally different feel for a web app.
Paradigm shift. And then Jesse James Garrett coined the term AJAX in February 2005.
Asynchronous JavaScript and XML.
Though, ironically, XML wasn't always the data format used. JSON often took its place.
But the concept stuck, communicating with the server behind the scenes.
Exactly. That asynchronous communication was the magic. It enabled single-page applications, SPAs, that felt responsive like desktop software.
And finally, for this period, March 2005, DevMo by Mozilla, now known as MDN.
Ah, MDN, Mozilla Developer Network. What a resource.
Especially back then, with all the browser differences, having a central, vendor-neutral place for documentation must have been invaluable.
Absolutely crucial. It became, and still is, the go-to place for reliable web standards documentation. Help developers navigate that tricky landscape.
Okay, so foundation laid, first wave of innovation done. Now we're heading into the late 2000s. Feels like library and framework time, and mobile.
You got it. March 2006. John Rizzig's first commit to jQuery.
jQuery. Write less, do more. Its goal was to smooth over those browser differences, right?
Yeah, that was the killer feature. DOM manipulation, handling events, making AJAX calls jQuery made it all so much easier and consistent across browsers like IE, Firefox, Safari.
Which were often wildly inconsistent.
A nightmare. jQuery abstracted that pain away. Its concise syntax was also a huge win. No wonder it got so popular and stayed popular for so long.
Still everywhere, really.
Yeah.
Then, January 2007, a device launches that changes everything, the iPhone.
And critically, Steve Jobs decides. No Flash support.
Big statement. What did that signal?
It signaled that Apple was betting on open web standards, HTML, CSS, JavaScript for the future of mobile content, not proprietary plugins like Flash. A major turning point.
A year later, February 2008, the official end of Netscape Navigator.
Yeah, kind of the final curtain call for the browser that started it all. Sad, but its legacy, especially JavaScript, was undeniable.
And the antitrust stuff against Microsoft played a role there, too. May 2008, Crockford's JavaScript The Good Parts book comes out.
We mentioned JSLint influencing it. The book itself really helped shift perception. It said, look past the quirks. JavaScript has elegant parts.
Helped legitimize it further.
Definitely.
Yeah.
Then, September 2008, Google enters the browser fray with Chrome.
And crucially, Chrome came with the V8 engine.
V8 was a beast. What made it so fast?
It compiled JavaScript directly to native machine code, and it used techniques like just-in-time, JIT compilation, huge speed boost compared to the interpreters of the day,
Game changer for web app performance. And Google open-sourced V8.
which had massive downstream effects like Node.js.
Exactly. But before Node, January 2009, we get Common.js. What was that about?
JavaScript was escaping the browser. People wanted to use it for scripting, for server stuff, but there was no standard way to organize code into modules like other languages had. Common.js tried to define that standard.
A way to require modules.
Yes, and building directly on that V8 engine and the need for server-side JS, Ryan Dahl starts working on Node.js in March 2009.
And suddenly, JavaScript isn't just for browsers anymore.
Right. You could build your backend in JavaScript, too. The dream of the full-stack JavaScript developer was born. Use one language everywhere.
Huge implications for productivity and team structure.
Quick side note, April 2009, Oracle buys Sun, which means they now own the JavaScript trademark.
Yeah, that planted a seed of concern in the community that pops up again later.
June 2009, first commit to Express.js. Still the go-to for so many Node.js apps.
Express provided that minimal, unopinionated layer on top of Node's core HTTP module, made building web servers and APIs much, much simpler. Its middleware concept is also really powerful.
Okay, wrapping up 2009, we get ECMAScript 5 in December.
ES5. More important additions. Strict mode. Use strict to catch common errors. Getters and setters. More array methods. Native JSON support. JSON.parse, JSON.stringify. Really solidified the language.
And also December 2009, CoffeeScript appears.
CoffeeScript. Compiled to JavaScript. Offered a cleaner, more Python-like syntax. Didn't take over the world, but it showed a hunger for syntactic improvements and definitely influenced future ECMAScript versions.
2010 kicks off with NPM 1.0 in January, Node Package Manager.
NPM. This arguably changed the JavaScript world more than almost anything else.
How so? Just a way to download code.
It was the way. A central place to find, share, and reuse JavaScript code. It created this massive collaborative ecosystem. Suddenly you could pull in libraries for anything, accelerating development like crazy.
The foundation for that huge ecosystem we have today.
Absolutely. Also in 2010, May, we get WebStorm 1.0, a proper IDE.
Right, moving beyond basic text editors. Features like code completion, debugging, refactoring, makes serious JS development much more pleasant.
Big productivity boost. And then, October 2010. Two big front-end frameworks arrive, AngularJS and Backbone.js.
The start of the modern SPA era, and as the post says, framework churn.
Yes. Apps were getting complex. Developers needed structure. These frameworks offered patterns like MVC or MVVM, data binding, ways to organize all that front-end code.
But lots of different ideas competing, hence the churn.
Exactly. Rapid experimentation to figure out the best way to build these new, complex browser apps.
Okay, so that sets the stage for the 2010s. Looks like a decade of massive expansion tools, frameworks, platforms.
It really was. June 2011, Node.js gets ported to Windows. Big deal for adoption.
Yeah, opened it up to way more developers who weren't on Mac or Linux.
And that porting effort actually led to the creation of Labov.
The underlying library that handles asynchronous I/O across different operating systems for Node.
Precisely. Cross-platform collaboration paying off. Then, March 2012, Webpack arrives.
Module bundling. Why did we suddenly need this?
Well, with Common.js and later ES modules, developers started writing lots of small JavaScript files. But browsers didn't handle loading hundreds of files efficiently. Webpack bundled them into fewer files, optimized assets like CSS and images too, crucial for front-end performance.
Got it. Managing all the pieces. October 2012, Microsoft releases TypeScript Beta publicly.
TypeScript, JavaScript with static types.
What was the main driver? Just catching errors earlier.
That was a big part of it. Catching type errors at compile time instead of runtime, but also making large code bases easier to understand, refactor, and maintain. Huge for big teams and complex applications.
A way to bring some structure and safety from languages like Java or C# into the JavaScript world.
You nailed it. 2013 rolls around another packed year. March, first commit to Atom Shell, which becomes Electron.
Electron, build desktop apps with web tech.
Yeah, JavaScript, HTML, CSS for cross-platform desktop apps. Think VS Code, Slack, Atom itself, all Electron apps. Lowered the bar for creating desktop software if you knew web dev.
February 2013, Mozilla releases Asm.js. What was that trying to solve?
Performance, especially for things like games or heavy computation in the browser. Asm.js was a very strict subset of JavaScript, that engines could optimize like crazy, getting near native speed.
Kind of a precursor to WebAssembly.
In spirit, yes. Proving that high performance was possible on the web, April 2013, the term mean stack gets coined.
MongoDB, Express, Angular, Node, all JavaScript.
It crystallized that idea of using JavaScript for the entire stack. Database, backend, frontend. Became a very popular combination for a while.
May 2013, Facebook releases React.
React, huge impact. Still dominant today.
What was so different about React?
It focused purely on the view layer, the UI. Introduced the concept of a virtual DOM for efficient updates, and popularized component-based architecture building UIs out of reusable pieces. Very declarative approach.
Made managing complex UIs much more tractable.
Definitely. Also in 2013, work starts on ESLint June and Gulp July. More tooling.
ESLint built on JSLint but was more flexible.
Yeah, pluggable rules, more configurable. Became the standard linter. Gulp was a task runner, like Grunt before it, but used streams for potentially faster builds, automating things like minifying code, running tests.
Streamlining the dev workflow. Okay, 2014, more frameworks. Vue.js in February.
Vue.js, created by Evan You, gained traction quickly.
Why Vue? What was its niche?
Often seen as easier to pick up than Angular or React initially. Very progressive, you could use just a little bit or build a full SBA. Good performance, great documentation. Hit a sweet spot for many developers.
July 2014, Strong Loop acquires Express. Caused a bit of worry.
Yeah, community concern about a core piece of the Node ecosystem being owned by one company. Would it stay open? Would development priorities change?
But it eventually landed safely in a foundation, right?
Yes, it moved to the OpenJS Foundation later, ensuring its neutrality. September 2014, first commit to Babel.js. Started as 6.5.
Babel, the transpiler. This let people use new JavaScript features before browsers supported them.
Exactly. Write modern ES6, or later code, and Babel would translate it back to older ES5 that worked everywhere. Absolutely essential for adopting new language features quickly.
October 2014, Meteor hits 1.0. Promised full-stack, real-time apps, simplified.
Meteor was very ambitious. Tightly integrated front-end and back-end, automatic data synchronization. Made real-time features easier to build initially. Maybe less popular now, but innovative for its time.
November 2014, Facebook launches Flow, another type checker.
Yep, Facebook's take on static typing for JavaScript. Competed with the TypeScript. Different approach, maybe less widespread adoption eventually, but showed the continued demand for type safety.
And AWS Lambda adds Node.js support. Serverless starts going mainstream.
Huge moment for serverless. Running back-end code without managing servers, Node.js was a natural fit given its event-driven nature, massively influenced back-end architecture.
Okay, closing out 2014, December, IO.js happens. A fork of Node.js.
Yeah, Fedor and Dutney and others forked Node.
Why? Frustration, mainly. Node.js development felt slow to some, particularly around adopting new V8 versions and ES6 features. IO.js aimed for faster releases and more open governance.
Created a bit of drama in the community.
It did, but it led to positive change. February 2015, the Node.js Foundation is formed.
Right, an attempt to bring stability and more formal governance, and by September 2015,
Node.js and IO.js merged back together.
a really important reconciliation. Showed the community could resolve major disagreements and move forward together under the new foundation structure, strengthen Node in the long run.
2015 also sees the term Jamstack coined.
JavaScript APIs and markup, a shift towards pre-rendering sites, using APIs for dynamic parts, focus on performance, security, scalability.
Getting away from traditional server-side rendering monoliths. September 2015, GraphQL is launched.
Facebook again, a query language for APIs.
How's it different from REST?
With REST, you often get fixed data structures from endpoints. Sometimes too much data, sometimes not enough, requiring multiple requests. GraphQL lets the client ask for exactly the data it needs in a single request. More efficient.
More power to the front-end developer.
Pretty much. June 2015 was super busy. Redux was released.
State management mostly for React apps.
Yeah, inspired by Flux and Elm. Provided a predictable way to manage application state, especially as apps got complex, became very popular alongside React.
Also June 15, the first release of WebAssembly, WASM.
WASM, the evolution of the idea behind asm.j, a low-level binary instruction format, lets you run code written in languages like C, C++, Air, Rust in the browser at near native speed.
Opening the door for really performance-intensive applications on the web.
Exactly. Games, video editing, CAD software, stuff that was hard with just JavaScript. And Atom 1.0, also released in June 15.
The Electron-based editor hits a stable milestone.
Yep. And the biggest news of 2015, arguably, July. ECMAScript 6, ES 2015, is finalized.
ES6. This felt like the biggest update to JavaScript ever.
It really was transformative. Classes, arrow functions, let and const, template literals, destructuring, promises, modules, the fetch API. Just a massive infusion of features that modernized the language.
Made JavaScript feel much more like other modern languages, really shaped the code we write today.
Absolutely. Fundamental shift. Okay, 2016 starts with a bit of a shock in March. The NPM left pad incident.
Oh yeah, that was crazy. One developer unpublished a tiny package, like 11 lines of code.
Called left pad. And it broke builds across the internet, including huge projects.
Because so many other packages directly or indirectly depended on it, what did we learn?
Showed the fragility of the ecosystem, the risks of deep dependency trees, and the importance of registry stability and security. A real wake-up call about supply chain vulnerabilities.
Definitely made people think more about their dependencies, but good things happened in 2016 too. April, Microsoft releases VS Code 1.0.
VS Code, from a niche editor to arguably the most popular code editor in the world now.
Why did it take off so fast?
It was fast, free, open source, mostly cross-platform, had great TypeScript integration out of the box, fantastic debugging, and a huge extension marketplace. Just hit all the right notes.
September 2016, Angular version 2 is released. A total rewrite.
Yeah, very different from AngularJS version 1. Embraced TypeScript fully, component-based architecture. Positioned as more of an enterprise-grade framework.
And October 2016, Next.js 1.0 arrives, focused on React.
Next.js brought easy server-side rendering, SSR, and static site generation, SSG, to React. Huge for performance, SEO, and building more robust React applications. Really influential framework.
So that brings us closer to the present. The modern era, 2017 onwards, still feels like things are moving fast.
No kidding. March 2017, work starts on the temporal proposal, finally tackling JavaScript's date object issues.
Let's hope. The built-in date object is notoriously tricky. Temporal aims for a modern, immutable, less confusing API for dates and times. Still ongoing, but much needed.
Absolutely. April 2017, Prettier 1.0 is released, the opinionated code formatter.
No more arguments about semicolons or spacing. Just run prettier.
Exactly. Enforces a consistent style automatically. Huge win for team productivity and code readability. Less time bike shedding, more time coding.
June 2017, ECMAScript 2017 lands, bringing async await.
Async await. Made asynchronous code look synchronous. Built on promises, but much cleaner syntax for handling chains of async operations. Big quality of life improvement.
Made promises much easier to work with. September 2017, Facebook launches Yarn, another package manager.
Yeah, Yarn aimed to be faster and more reliable than NPM at the time. Introduced lock files for deterministic installs. Spurred competition, which ultimately made NPM better too.
Also, September 2017, Cloudflare Workers launches. Serverless at the edge.
Right. Running JavaScript on Cloudflare CDN servers, close to the user. Great for performance-critical tasks, modifying request responses on the fly, A/B testing. A new paradigm for serverless.
January 2018, Google releases Puppeteer 1.0 Headless Chrome Control.
Super useful tool. Automate browser actions testing, scraping, generating screenshots or PDFs. Made interacting with browsers programmatically much easier.
March 2018, TensorFlow.js arrives. Machine learning in the browser.
Yep. Run ML models directly in the user's browser with JavaScript. Opens up cool possibilities for on-device AI, privacy-preserving ML, interactive visualizations.
Pretty amazing stuff. June 2018, Smushgate. What was that about?
It was about a proposed new array method, array.prototype.flatten. But an old library called MooTools already added a method called flatten-to-array-prototype, and the new proposal would break sites using MooTools.
So they had to rename it.
Yep, it eventually became flat, showed the challenges of evolving the web platform without breaking existing stuff. Backward compatibility is key. Also in June 2018, Ryan Dahl teases Dino publicly.
Right, his things I regret about Node.js talk. What were the main regrets he aimed to fix with Dino?
Security was a big one. Node apps having broad system access by default. Reliance on NPM and the centralized registry. Lack of built-in TypeScript support. Dino aimed for secure by default, modules loaded via URLs, first-class TS support. ECMAScript 2018 and 2019 kept coming, adding smaller but useful features each year.
Those yearly releases keep the language moving forward steadily. March 2019, the JS and Node.js foundations merge into the OpenJS Foundation.
Consolidating governance, bringing key projects under one roof to foster collaboration and ensure the health of the overall JavaScript ecosystem.
And Node.js finally gets proper support for ECMAScript modules, ESM.
Yes, first experimental, then stable. A long time coming. Aimed to bridge the gap between Node's common JS modules and the standard module system used in browsers. Still an ongoing transition for the ecosystem.
May 2020. Cool moment. JavaScript is running the touchscreens on the SpaceX Dragon.
That's quite the validation. Shows how far JavaScript has come in terms of capability and reliability. Also, May 2020, Dino 1.0 was released.
Dino hit stability, ready for prime time.
That was the signal. A viable, modern alternative to Node.js, built with lessons learned.
The early 2020s also saw the end of some old tech. Flash officially sunsetted December 2020.
Good riddance, many developers would say.
And Internet Explorer 11 finally retired in June 2022.
Another milestone. Marked the end of an era and simplified testing for web developers significantly.
ECMAScript keeps chugging along yearly. September 2023, Bun 1.0 launches. Yet another runtime.
Yep, Bun. Written in Zig, all about speed. Built-in bundler, transpiler, task runner, package manager. Aims to be an all-in-one, faster toolkit, gaining a lot of buzz.
Competition keeps heating up in the runtime space. 2024, Node gets a mascot. Rocket Turtle.
Yes. Community vote. Cute. March 2024 JSR launches.
A new JavaScript registry from the Dino team. What's the goal?
Aiming to be a modern registry, built for TypeScript first, better docs generation, designed to work across runtimes, Dino, Node, Bun, browsers, trying to improve on NPM's perceived shortcomings.
Interesting. And the hashtag Free JavaScript legal battle against Oracle kicks off in September 2024.
Yeah, revisiting that trademark issue from the Sun acquisition. Community effort pushing for the JavaScript trademark to be truly open, removing Oracle's control. High stakes.
October 2024, Dino 2 is released, and the big news is Node and PM compatibility.
That's huge for Dino. Makes it much easier for Node developers to try Dino or migrate projects without rewriting everything. Lowers the barrier significantly.
Okay, looking ahead to 2025, TypeScript potentially getting a Go-based compiler for speed.
That's the plan for TypeScript 7.0. Could mean much faster type checking, especially for large projects.
And Microsoft planning to open source VS Code's Copilot chat extension, AI becoming more integrated.
Definitely a trend. More AI assistants built directly into developer tools, helping with coding, debugging, learning.
So faster runtimes, smarter tools, AI integration seems to be the direction.
It really does. What a 30-year ride, huh? From that quick 10-day script to, well, this, powering almost everything.
It's an incredible story of open source, community, a giant ecosystem, and just constant relentless change and innovation.
Absolutely. And you get the feeling it's far from over. The pace doesn't seem to be slowing down much.
Which leads to the final thought. Considering how much has changed, often unexpectedly, what's the next big disruption or evolution waiting around the corner for JavaScript? And do these patterns we've just discussed give us any hints? Something to chew on?
Definitely something to think about. It's been fun tracing this history.
It really has. Thanks for taking this deep dive with us.